Hi ladies, in this video we're going to go through some questions from 3i. So 3i looks at exponential equations. There's not really much theory for this because you've done a lot of it already just in the skills that you've developed, and it basically just takes practice. So it looks a bit daunting at first, but because you'd probably never solved for x as a power, but you'll get the hang of it and you'll be, I think, quite good to go. All right, so let's start off easy. Let's just have a look at question 1. Okay, so 1a, part I, what have we got? 5x is equal to 25. So what we want is we want both the left-hand side and the right-hand side to be in the same base, to the same base. So the base here is 5. So that means we want the right-hand side also to be base 5. So we rewrite 25 with the base 5. So 5 to the power of what gives us 25? Is 2. Okay, so 5 squared is 25. And then your power, because our bases are the same, your powers must equal each other. So x is equal to 2. All right, second one. We've got 2x is equal to 8. Again, the bases have to be the same. So the base for the left-hand side is 2. So we write 8 as a base 2. 2 to the power of what gives me 8? 2 to the power of 3. So now that your bases are the same, you can say, all right, the powers have to be equal. Let's have a look at, I'm not going to keep going. Let's go to question 2. Otherwise, we'll be here forever. Okay, so now we've got 3x is equal to 27. So your base is 3. So I'm going to rewrite 27 as a base 3. So 3 to the power of what gives you 27? It's 3 to the power of 3. So this is where it helps to know your powers. Okay, just trying to think of it. Oh, they're all a little bit hard. Yeah. Okay, let's look at a harder one. Let's look at 7. Oh, sorry, not 7. L, which is 7x equals 343. Now this one here, we'll just say, all right, I'm going to assume that we've got the base 7 on both sides. So 7 to the power of what gives me 343. So I know 7 to the power of 1 is 7. 7 to the power of 2 is 49. 7 to the power of 3 is 49 times 7. And when you think about that, that's roughly 50 times 7, which is 350. So you can safely assume that it's going to be 3. So when you get the higher numbers, it does look a little bit daunting, but when you just work it out like that, you're like, oh, it doesn't take long for it to increase. So when you think of coronavirus right now, things are, well, not necessarily here in Australia, but when things take off, it goes exponentially. So that's what it actually means by exponential equations. They increase rapidly. Okay, I don't want to talk about the coronavirus, so let's move on. Okay, now question 3, again, looks hard, but isn't. Okay, so let's just do 3a. We've got 7x is equal to 1 over 49. Now, we've got the base of x, so I'm going to rewrite that 49 something to the base of x. So it's 7 squared is 49. Now, when we did negative indices, you should know that you can rewrite 1 over 7 over 2 is 7 to the power of negative 2. So x is equal to negative 2. All right, let's do maybe g. It's slightly different. This is 3 to the negative x is, sorry, I just lost track of which question I was up to. I have to scroll so I can, scroll. All right, so our base is 3. Don't worry about this being a negative x. You can rewrite this if you wanted to be 1 over. Actually, we might do both ways. We can rewrite that as 1 over 3 x is equal to 1 over 3 squared. So that means x is equal to 2. Or you can say, I'll just put a line here to show that we've got a different working out. 3 to the negative x is equal to 1 over 3 squared. So x, I don't like that blue circle, go away, right, is 3 to the negative, oh gosh, that should be a 3, sorry. I'm getting distracted. 3 to the negative x is equal to 3 to the negative 2. So we've got negative x is equal to negative 2. So x is equal to 2. So it might seem that this first way is a little bit easier, but we tend to work all them out that way. All right, I might push on. So I don't know how to get to another page without doing this weird inserting a new page, which is a bit annoying, but we'll just do that. And I do Word because other documents I can't write on. Okay, so let's look at question 4. Okay, we'll start with the easy one. 9x equals 27. Now we want them to be in the same base. Okay, so, and obviously you can write, sorry, you can't write 27 with a base 9. So you can't say, all right, let's use the base 9 because 27 can't be written with a base 9 with a whole number power. So let's rewrite 9 as 3 squared. Okay, and then we'll just pop that x there. And then 27 is 3 to the power of 3. Now, think back to your index laws, when you've got a power inside and a power outside, it's just 3 to the power of 2x. And then we've got 3 to the power of 3. So now I've got the same bases, so I'm going to let my powers equal each other. So x is equal to 3 over 2. Okay, and let's do another one. Let's do 32x equals 2. Okay, so I'm going to write 32 to the base of 2. So 2 to the power of 5. Sorry, sometimes I talk and I don't know whether I'm making sense. Which is probably what you don't want to hear. Okay, so 2 I'm just going to write to the power of 1 for now, okay, because it is a power, and that will just help us solve it. So 2 to the power of 5 to the power of x, so it's 2 to the power of 5x is equal to 2 to the power of 1. We've got the same bases, so we're going to let the powers equal each other. So x is equal to 1/5. Okay, so just taking your time. All right, let's have a look at question 6. So I'm not going to do that word problem because I want to do a few videos for you tonight. So if you have problems with anything that I'm not covering, please let me know. Okay, 6a, what do we got? 2x plus 1 equals 8x. Okay, so it's the same thing, having the same bases. So 2 to the power of x plus 1. 8 can be rewritten as 2 to the power of 3. And oops, that x should be at the top. Sorry about that. Let me just scribble that out and put it up there. So what do we got? Same, oops, let's just expand this first. So 3x. Okay, so now we've got the same base, 2. So now I've got x plus 1 equals 3x. All right, bring your x's to the same side. So I'm going to bring that x over by subtracting x. So we've got 2x, and then I'm going to divide both sides by 2. So x is equal to 1/2. Let's just do another one because I don't want to always do the easy ones. All right, let's do J. J looks pretty hard. I also think I'm running out of room. So can I move? I wonder if I can move this over. Just give me a bit more space. Okay, so J, what do we got? 27, 2x plus 3 is equal to 9 to the power of 2x minus 1. So again, I need to write them to the same base. So I'm going to write 27 is 3 to the power of 3. And that's 2x plus 3. And then 9 is written as 3 squared, 2x minus 1. Now just be careful. Might be a good idea to put all of this in brackets, because when we're multiplying, we're actually multiplying both terms in the bracket. So it's going to be 3 times 2x, which is 6x, and then 3 times 3, which is 9. These ones are getting trickier. Oops, that shouldn't have been an equal sign. Oh, that should have been an equal sign. And that's just me scribbling out. What are we doing? 2 times 2x is 4x. 2 times 1. So it's 2 times negative 1. Can't even read my own writing. Negative 2. Now that we've got the same bases, I can just let the powers equal each other. Okay, bring your x's over to the same side. So I'm going to subtract 4x from that side. So subtracting 4x from 6x gives me 2x. And in the same step, I'm going to take that 9 over. So it's going to be negative 11. And I'm just going to pause there just to make sure I haven't made a mistake anywhere. Sometimes when I get numbers I don't like, I feel like I've made a mistake. All right, negative 11 divided by 2 is negative 5.5. Okay, I just wanted to pause that just to make sure I was right. Okay, so the answer is left it as negative 11 over 2, which is the same as negative 5.5. So we're good to keep going. All right, I'm going to leave it there. If you can do up to question 6, that is awesome. So you can just hear my dog shaking her head in the background. You right there, Lucy? She's scratching her head. All right, girls, I'm going to leave it there. Please, this topic, very difficult. I've only done a few questions, so just take your time, and with anything you need further help with, you need to let me know. Okay, bye.